Lesson 10, Operational Amplifier. Section 10.10. Low output resistance. Next, let's focus on the output circuit. TR9 is working as a current source, and the current I9 is constant. This is the equivalent circuit for the AC components of this output circuit, where HOE8 and HOE9 are output conductances of TR8 and TR9 respectively. In section 4.2, HOE was neglected due to its small value. Here we need to consider HOE. This equivalent circuit can be rearranged into this circuit. In exercise 3.4.2, HOE was approximately 6 microsiemens. Assuming that HOE9 is the same amount, RO is calculated to be in the order of several tens of kilo-ohms. On the other hand, that of the TL082CP is several hundred ohms. Exercise 10.10. This is your homework. Pause the video, and answer the problem. We need an additional circuit to reduce the output resistance. This is the solution for reducing the output resistance. This circuit is called a power amplifier or push-pull amplifier. Experiment 10.10. This is to measure the input-output relationship of a power amplifier. The circuit in A is a power amplifier. In the circuit in B, the diodes D1 and D2 are short-circuited. This is to check the function of these diodes. These are the results of the circuit in A. The top figure shows the waveforms of the input Vs and the output VOG1. The bottom figure shows the relationship between the input and output. The output was almost proportional to the input. The voltage gain was about 0.92. These are the results of the circuit in B. There was a dead zone. Within the range that the absolute value of Vs was approximately smaller than 0.6 volts, the output was 0. The forward bias voltage VD1 plus VD2 of diodes D1 and D2 serves as the bias voltage VBE1 plus VBE2 of transistors TR1 and TR2. D1 and D2 are called biasing diodes. These are the waveforms of Vs and VOG1. At T equals T1, Vs equals 0 volt and VOG1 equals 0.65 volts. The base voltage of TR2 is equal to Vs, and it is 0 volt. The output voltage VOG1 is higher by VBE2, thus VOG1 equals 0.65 volts. The base voltage of TR1 is higher by VBE1 from the output voltage. So it is 1.3 volts. TR1 is conducting, and the output current I/O is flowing through TR1 and RL. At T equals T2, Vs equals negative 0.9 volts, and VOG1 equals negative 0.25 volts. At this time, the base voltage of TR2 equals negative 0.9 volts, the output VOG1 equals negative 0.25 volts, and the base voltage of TR1 equals 0.4 volts. TR2 is conducting, and the output current I/O is flowing through RL and TR2. When VOG1 is positive, this amplifier pushes I/O out to the load. And when VOG1 is negative, this amplifier is pulling I/O in from the load. Thus, this amplifier is called a push-pull amplifier. This is the circuit in the state where TR1 is conducting. When TR2 is conducting, the active circuit is shown in B. Both the circuits are common collector amplifiers. According to section 4.4, these two circuits are represented by this equivalent circuit. This is a combination of high-gain amplifier and the push-pull amplifier. The equivalent circuit of this high-gain amplifier is represented by this circuit. According to Hothevanen's theorem, this circuit can be converted to this one. The push-pull amplifier is represented by this equivalent circuit. These equivalent circuits are combined to form a single circuit. According to exercise 4.4.1, RO is given by this equation, and it is 440 ohms using the parameters in section 3. Note that this value is a rough estimate because the characteristics of the transistors in the TL082CP are not available from the datasheet. Section 10.11. Operational amplifier. This is a schematic diagram of the TL082CP. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.